All right, let's start with the evidence. Number 10. Doggerland, beneath the North Sea. Beneath the gray floor of sea, scans have traced buried river channels, marshes, and valleys where fishing boats now cross open water. The map is unmistakable. Between Britain and continental Europe, there was once a vast inhabited landscape. That is the contradiction. What looks like empty seabed was not always sea, and Britain was not always an island. Stone tools, worked bone, human remains, and sediment cores recovered from this drowned region point to a place where Mesolithic communities could hunt, gather, travel, and return to familiar ground. So what happened to the people when that ground began to disappear? These are not maps drawn by prehistoric hands. They are scientific reconstructions built from seabed topography, seismic data, ancient sediments, and changing sea levels. Together, they reveal something more disturbing than a single legendary flood. Rivers became estuaries, plains became islands, human routes vanished beneath advancing water. Doggerland is only the first missing world, and by the final map, the question will no longer be how much land the sea took, but how much human history went down with it. The first clues did not come from a grand underwater excavation. They came up in fishing nets. For decades, trawlers working the North Sea hauled in more than fish. Mammoth bones, antler tools, worked flint, and fragments of human remains. Many were scattered finds, stripped from their original context by currents and dredging. But taken together with seismic surveys and sediment cores, they pointed toward a landscape far more complex than a narrow land bridge. Doggerland held river systems, wetlands, lakes, low ridges, and broad plains beneath cold, open, post-Ice Age skies. Some areas would have supported red deer, wild cattle, boar, fish, waterfowl, and edible plants. For mobile hunter-gatherers, this was not marginal ground. It was the kind of place where food, fresh water, and movement routes converged. The immediate question is not whether people crossed it. They almost certainly did. The harder question is how long they stayed, and what happened as the coastline moved inward, generation after generation. Sea level rise after the last ice age was not a single wall of water arriving in one afternoon. Much of the loss unfolded over centuries. A familiar river mouth could widen. A marsh could turn brackish. A hunting ground might become an island, then vanish entirely. Families would not have watched a world disappear on a map. They would have experienced it as a sequence of local losses. A path no longer reached the same camp. Fresh water became harder to find. Groups that once met across open ground may have been pushed onto opposite shores. There may also have been sudden shocks. The Storegga submarine landslide, off Norway, generated a major tsunami roughly 8,000 years ago. Deposits around the North Atlantic show that the wave reached parts of Britain and surrounding coasts. Whether it destroyed the last communities of Doggerland remains debated, because much of the region had already been reduced by rising seas. That distinction matters. The tsunami may have struck a shrinking landscape, but it was not the sole cause of its disappearance. The evidence payoff is clear. Doggerland was a real post-Ice Age environment used by human communities, and its drowning removed both habitable land and much of the archaeological record those people left behind. What survives is incomplete. Tools without camps, bones without burials, channels without the names once given to them. Yet even this broken record proves that an entire human landscape can vanish while history continues on either side of the water. The next map reveals an even larger lost world, where Asia and North America were not separated by an ocean, and where people may have lived for generations in the space between continents. Number 9. Beringia, the continent between continents. A core of frozen sediment, taken from Alaska's Seward Peninsula, contains pollen, plant fragments, and layers of wind-blown dust from a landscape that no longer appears on any modern map. Add mammoth bones, ancient lake deposits, and the shallow contours beneath the Bering Strait, and a vanished country begins to emerge between Siberia and Alaska. It is often called the Bering Land Bridge. The name is convenient, but misleading. A bridge sounds narrow, temporary, and empty. A strip of ground crossed as quickly as possible. Beringia was something much larger. At times of low sea level, it formed a broad region stretching across what is now the Bering and Chukchi Seas, joining northeastern Asia to northwestern North America. The first surprise is that this was not a continuous wall of ice. Much of central Beringia was cold and dry, with steppe tundra vegetation capable of supporting mammoths, horses, bison, caribou, and other grazing animals. Rivers cut across the lowlands. Uplands offered shelter from flooding. In the right seasons, human groups could find meat, plants, fresh water, fuel, and routes through an environment that was harsh but not lifeless. So, were people simply moving through Beringia on their way to the Americas? Or did some remain there long enough for this drowned landscape to become home? That question matters because genetic studies of ancient and living populations have suggested that the ancestors of many indigenous peoples of the Americas became isolated from other Asian populations before spreading farther into the continent. One explanation, often called the Beringian standstill model, proposes that part of this isolation occurred somewhere within Greater Beringia. The map makes that possibility easier to understand. During colder periods, ice sheets blocked routes farther east, while mountain systems and changing habitats limited movement elsewhere. A population entering Beringia may not have found an open corridor into the rest of North America. It may have encountered a vast ecological refuge bounded by obstacles. For the people living there, isolation would not have felt like a theory. It would have meant winter darkness, repeated journeys to familiar rivers, dependence on migrating herds, and generations born into a world whose eastern and western limits they may never have crossed. The genetic pattern is real, but it does not identify a campsite beneath the sea. Researchers still debate exactly where the isolation occurred, how long it lasted, and which routes later carried people south. Coastal travel, interior corridors, and multiple movements may all have contributed at different times. Yet the environmental reconstruction changes the human story. People did not have to survive on a featureless strip between continents. They could have occupied a broad mosaic of river valleys, plains, and uplands, following animal herds and adapting their movements to seasons that would have been severe even by Ice Age standards. Then the climate shifted. Ice melted. Sea level rose. Low ground disappeared first, dividing the region and forcing people toward higher land in Siberia, Alaska, and the Yukon. A connected world became two continental margins separated by water. The clear payoff is this. Beringia was not merely a crossing point. The map strongly supports a lost, habitable region large enough to shape migration, isolation, and the early population history of the Americas. What the sea removed was more than the route itself. It likely submerged many of the camps, hunting places, and river crossings that could show how people actually lived during this critical chapter. Archaeologists are left with evidence around the edges, while much of the central landscape remains beyond ordinary excavation. Doggerland showed how water could erase a homeland between neighboring shores. Beringia widens the scale. Here, the drowning of one landscape helped turn a connected Ice Age world into two continents. But the next map reveals a different transformation. In Southeast Asia, the sea did not simply separate two sides. It broke one enormous tropical landmass into the islands we recognize today. Number 8. Sundaland, the drowned heart of Southeast Asia. A sediment core taken from the Sunda Shelf contains grains of pollen, fragments of ancient plants, and layers of earth laid down when the sea above it was still dry land. Around that buried soil, modern maps show water separating the Malay Peninsula from Sumatra, Java, and Borneo. Ice Age maps show something radically different. One immense tropical landmass stretching across much of what is now maritime Southeast Asia. The islands were real highlands, but the water between them was not always there. During periods of low sea level, broad plains connected large parts of the region. Rivers that now end at separate coasts once continued across the exposed shelf, joining into drainage systems that crossed hundreds of kilometers before reaching the distant sea. Recent reconstructions have traced several of those paleo rivers beneath the shelf, while submerged animal remains confirm that terrestrial ecosystems once occupied places now covered by one of the world's largest shallow seas. That changes the human picture immediately. A person standing in central Sundaland would not have seen an ocean filled with scattered islands. He might have seen open lowlands, forest mosaics, wetlands, and long river corridors leading toward uplands that would later become Sumatra or Borneo. How many people followed those rivers, hunted along their banks, or built temporary camps on ground now hidden beneath mud and salt water? The map can identify the landscape, but direct archaeological evidence from its drowned center remains scarce. Most confirmed prehistoric sites lie around the surviving margins, in caves, river valleys, and elevated ground that escaped inundation. That absence creates a dangerous temptation. It is easy to imagine lost cities where no evidence exists. It is equally easy to treat the submerged shelf as empty simply because ordinary excavation cannot reach it. The more defensible answer lies between those extremes. Human beings were present in the wider region while Sundaland was exposed. Animals moved across some of the same connections. Reconstructed river networks reveal natural routes linking areas that modern geography makes appear isolated. Those routes would have concentrated fresh water, fish, plants, game, and movement through an otherwise enormous landscape. The environment was not uniform. Some reconstructions once pictured a broad savanna corridor running through the center of Sundaland. Newer pollen and ecological work suggests a more complicated mosaic, with forests, seasonal woodlands, open patches, wetlands, and changing habitats responding to rainfall as well as temperature. For people moving through the region, survival depended on reading those local differences rather than crossing a single, featureless plain. Then the coast began moving inland. The change unfolded across generations, but it did not make the consequences gentle. A river valley could become an estuary. Salt water could contaminate a familiar freshwater system. Low camps would be abandoned, then covered. As channels widened, communities that had once moved overland between regions faced longer detours or water crossings. High ground became peninsula, then island. Genetic studies have linked periods of rising sea level with major shifts in population movement between Sundaland and neighboring regions. Genetics cannot locate the drowned camps or tell us what individual families decided. It can, however, preserve signs that populations moved, contracted, mixed, or became separated while the geography around them changed. The evidence payoff is therefore larger than the outline of a lost continent. Sundaland shows that the modern island world of Southeast Asia was created in part by the drowning of a connected human landscape. The sea did not merely remove territory, it reorganized routes, divided habitats, and changed who could reach whom without crossing water. Yet one boundary remained even when the shelf was fully exposed. East of Sundaland, deep channels never became dry land. Beyond them lay another vanished continent, Australia, joined to New Guinea and Tasmania. But reaching it required something none of the first maps demanded. People had to cross open sea before they could walk across Sahul. Number 7. Sahul, beyond the drowned horizon. At Maja Bebe, a sandstone shelter in northern Australia, archaeologists found ground stone axes, grinding stones, ochre, and the remains of plant foods in layers dating deep into the Pleistocene. These objects belonged to people who had already reached a continent that no walking route from Asia could reach. On an Ice Age map, that continent looks unfamiliar. Australia, New Guinea, Tasmania, and the exposed shelves between them form a single enormous landmass known as Sahul. Its northern coastline extended far beyond the modern shore. The Gulf of Carpentaria was largely dry. New Guinea's mountains rose from the same connected ground as Australia's interior. Yet the map also exposes the central contradiction. Lower sea level joined the parts of Sahul together, but it never joined Sahul to Southeast Asia. Deep channels remained across Wallacea, the island region between Sundaland and the Australian continental shelf. Anyone entering Sahul had to cross open water first. How did a population without metal ships, charts, or compasses reach land that could sometimes lie beyond the visible horizon? The strongest answer begins with the geography. Route models reconstruct chains of islands where travelers could move eastward in stages, watching currents, winds, birds, clouds, and distant mountain silhouettes. Some crossings may have offered visible targets. Others required leaving shore without certainty that the next land could be seen. This was not one lucky person clinging to driftwood. Accidental arrivals would have struggled to establish a lasting population. Demographic modeling, instead, supports repeated, organized voyages involving enough men, women, and children to build viable communities. The exact route remains disputed, but the successful settlement of Sahul strongly implies planning, cooperation, and seafaring knowledge passed between people. Once ashore, the travelers did not enter an empty version of modern Australia. They entered a larger and ecologically varied continent. Tropical lowlands stretched across the north. Highland valleys cut through New Guinea. Grasslands, deserts, woodlands, lakes, and river systems shifted as climate changed. Giant marsupials and other animals occupied environments that later contracted or vanished. The map, therefore, changes the question from how people landed to how they spread. Recent mobility models combine reconstructed terrain, water sources, and likely foraging behavior to estimate how groups could move through Sahul. The most practical routes were not always the straightest. Rivers could guide travel. Lakes could pull people toward reliable water. Mountain chains could block movement or provide visible landmarks. A coastline that looks like an edge on a modern map may once have been the beginning of a broad plain. The archaeological record shows that people reached widely separated parts of Sahul remarkably early. Majid Bebe preserves evidence of long-term occupation in the north. Other early sites appear far to the south and east, even allowing for debate over the oldest dates. The larger pattern is difficult to avoid. After the maritime crossing, human communities expanded through an immense, unfamiliar landscape. The payoff is clear. Sahul was not simply a larger Australia revealed by falling seas. It was the destination of one of the earliest major open water dispersals in human history, followed by a rapid continental expansion made possible by shared knowledge, flexible movement, and deliberate settlement. The artifacts at Majed preserve part of that achievement, but the first arrival coast may no longer exist. Rising seas flooded the broad northern shelves where newcomers could have landed, camped, and begun moving inland. The map points toward entry zones now buried offshore, leaving later shelters to record a journey whose first footsteps have been erased. And the drowning did something else. It did not only shrink Sahul around its edges. In the north, water entered a vast low basin between Australia and New Guinea, transforming what may once have been a freshwater heartland into the Gulf of Carpentaria. That lost center is where the next map leads. Number 6. Lake Carpentaria, Sahul's lost interior. A sediment core drilled beneath the Gulf of Carpentaria contains shells, pollen, microscopic algae, and layers of mud deposited when this shallow sea was something else entirely. On a prehistoric map of Sahul, the water between northern Australia and southern New Guinea retreats, revealing a vast, low basin enclosed by land. At different stages of the Ice Age, that basin held rivers, wetlands, exposed plains, and a large lake commonly called Lake Carpentaria. Its size and salinity changed with rainfall, evaporation, and the movement of the sea. Sometimes it appears to have been relatively fresh. At other times, it became more brackish or fragmented as the climate dried. The modern Gulf looks like a barrier. The older map suggests that the same space may once have acted as a center. Rivers descending from the surrounding uplands would have carried water, sediment, plants, fish, and animals into the basin. Wetlands could have supported water birds and edible vegetation. Open ground around the margins may have attracted grazing animals. For people moving between northern Australia and southern New Guinea, the lost lowlands could have offered routes, seasonal resources, and familiar stopping places across what is now open sea. But did human communities actually live beside Lake Carpentaria? The physical landscape is well supported by sedimentary and environmental evidence. Direct archaeological evidence from the drowned basin is much harder to obtain. No map can place a family beside a particular shoreline or identify a camp beneath hundreds of kilometers of shallow water. The most likely human story must therefore be reconstructed from the basin itself, from occupation around the surviving margins, and from what is known about how hunter-gatherers used rivers, wetlands, and reliable freshwater. That limitation does not make the map empty. It reveals why the evidence is missing. A low basin, rich in water, would have changed repeatedly as the climate shifted. In wetter periods, the lake could expand and divide movement around its shores. During drier intervals, exposed lake margins and shrinking channels may have concentrated people and animals near the remaining water. Routes that worked for one generation could become useless to the next. Then, rising seas approached from the northwest. As global ice melted, salt water moved through the lowest openings and entered the basin. The change was not necessarily one sudden catastrophic wave. Marine influence increased in stages, turning freshwater environments into estuaries and then into a broad, shallow gulf. Mud, salt, and later marine sediment covered surfaces that had once been exposed to wind, animals, and possibly human feet. The human consequences would have extended beyond simple loss of land. Freshwater sources disappeared or shifted inland. Groups using the basin's margins had to retreat toward higher ground. Travel routes between Australia and New Guinea narrowed, then broke. Communities that once occupied one connected continent increasingly found themselves on opposite sides of expanding water. Genetic, linguistic, and archaeological histories in the wider region preserve complex connections between the peoples of New Guinea and Australia, but they cannot recreate every relationship that existed before the Gulf formed. Geography separated populations without erasing every trace of older contact. The payoff is clear. The Gulf of Carpentaria covers a major Ice Age landscape within Sahul, one that changed from exposed lowland and lake country into sea. Its drowning did not merely shorten a coastline. It removed a potential ecological center and helped divide one connected continent into increasingly separate human worlds. The sediments preserve the environmental sequence, but not the voices of those who watched the water advance. They record fresh water becoming salt, open ground becoming seabed, and an interior basin becoming a maritime boundary. And that changes the investigation. The first 5 maps showed that rising seas could erase plains, routes, and continental connections. The next 5 ask a more difficult question. When the most attractive human landscapes disappear underwater, how can archaeologists separate a lost homeland supported by evidence from one created by imagination? The next case begins beneath the Persian Gulf, where buried river systems inspired one of the most compelling and most contested visions of a prehistoric refuge. Number 5. The Gulf Oasis. A sonar profile beneath the Persian Gulf reveals a broad basin crossed by buried channels. Today, warm salt water covers the space between Arabia and Iran. During the coldest phases of the Ice Age, much of that basin was dry land, and rivers descending from Mesopotamia, the Zagros Mountains, and the Arabian interior flowed toward its lowest ground. This lost map has inspired one of the boldest ideas in Arabian prehistory: that the exposed Gulf formed a well-watered refuge where human populations could survive, while surrounding deserts became colder and drier. The attraction is obvious. The basin sat between Africa, Arabia, Iran, and southern Asia. Springs may have emerged where underground aquifers reached the surface. Rivers, wetlands, and lakes could have concentrated fish, plants, game, and fresh water. In a region defined today by aridity, the drowned floor of the Gulf appears on reconstruction maps like a hidden green corridor. But did people actually live there in significant numbers? Or are we allowing the shape of the landscape to create a human story before the artifacts have been found? Along the Gulf's surviving margins, archaeologists have documented stone tools and settlements from different prehistoric periods. Farther inland, caves and open-air sites show that human groups occupied parts of Arabia whenever rainfall, lakes, and rivers made movement possible. The wider region was not an empty barrier. Populations entered, withdrew, and returned as climatic windows opened and closed. The submerged basin could have participated in those movements. Yet the central evidence remains uneven. Ancient river systems and changing shorelines can be reconstructed from geology. Habitable zones can be modeled. What has not yet been recovered in comparable strength is a dense chain of securely dated camps across the drowned Gulf floor. That gap matters because a refuge is more than a place where survival looks possible. It requires evidence that people were present when conditions elsewhere became hostile, and that the landscape helped sustain them. There is another complication. The Gulf did not remain equally fertile through the entire Ice Age. River discharge, rainfall, temperature, and evaporation changed repeatedly. Some periods may have produced lakes and wetlands. Others may have left large areas dry, salty, dusty, or difficult to cross. A single green map can hide thousands of years of environmental instability. Even so, the reconstruction produces a serious archaeological consequence. When sea level began rising after the last glacial period, water entered the basin from the southeast. Shorelines moved northward. River mouths shifted. Springs and low wetlands were submerged. Any communities using those environments would have been pushed toward Arabia, Iran, or Mesopotamia as the available ground narrowed. By the early Holocene, the advancing sea had transformed the basin into the Gulf. Soon afterward, settlements became increasingly visible around its new shores. Some researchers have asked whether this apparent expansion records populations displaced from the drowned interior. It is a compelling possibility, but the timing alone cannot prove it. Coastal growth could also reflect new technologies, changing economies, or people arriving from elsewhere. The payoff is more precise than the legend. Geological evidence confirms that the Persian Gulf covers a large prehistoric landscape with river systems and potentially attractive refuges. Archaeology confirms repeated human occupation around the region. Together, they make settlement of the exposed basin plausible, but they do not yet reveal a lost civilization, a single exodus, or one population preserved there in isolation. That restraint makes the map more useful, not less. It tells archaeologists exactly where a major missing archive may lie, while refusing to treat possibility as discovery. The next map brings the search back onto firmer ground. Beneath the northern Adriatic lies a drowned plain whose rivers, animal routes, and surviving shoreline sites allow us to see how an apparently coastal settlement may once have stood far inside a much larger landscape. Number 4. The Great Adriatic Plain. Beneath the northern Adriatic, marine surveys have mapped a buried river valley almost 10 kilometers long, cut into ground that is now sealed under mud and seawater. Along the surviving edges of that vanished plain, caves and rock shelters contain flint blades, hearth debris, and the bones of bison, horses, ibex, and other animals hunted during the coldest phase of the last ice age. Placed on a modern map, those sites appear coastal or close to the sea. 20,000 years ago, many of them faced something else. An immense alluvial lowland extending between Italy and the Balkans, with the shoreline far to the south. Beyond broad valleys, no traveler standing there would have recognized as a future seabed. Researchers call it the Great Adriatic Po Plain. At the last glacial maximum, sea level stood roughly 120 meters lower than today. The Po and other rivers crossed exposed territory that now forms the shallow northern Adriatic seabed. Braided channels, gravel bars, wetlands, grasslands, and patches of woodland spread across one of the largest plains in the Mediterranean region. The contradiction is severe. Modern geography makes the Adriatic look like a barrier between two shores. For Ice Age hunter-gatherers, its northern basin may have been connective land, a broad survival landscape linking the Alps, the Apennines, and the northwestern Balkans. What would life have looked like across that open ground? Animal bones and stone tool assemblages from sites around the margins show that people hunted in several ecological zones. Bison and horses moved through lower country. Ibex occupied rocky uplands. Rivers carried fresh water and drew animals into predictable corridors. A group could shift between foothill shelters and the plain according to season, weather, and the movement of herds. The buried valleys confirm that this was not a blank shelf exposed by falling seas. It had drainage systems, changing soils, and habitats arranged around water. Those features are exactly the kinds of places in which mobile communities repeatedly left camps, butchered animals, repaired tools, and waited for game. But most of the evidence from the center is gone from reach. No secure chain of Paleolithic camps has yet been excavated across the drowned plain itself. Sediment from the Po and later marine deposits may have buried some surfaces deeply. Erosion may have destroyed others. Fishing, construction, and currents disturb the seabed. Archaeologists, therefore, see the edges clearly, while the middle of the human landscape remains largely hidden. This creates a distortion. A cave that preserves thousands of stone flakes can appear to be the center of prehistoric life simply because caves survive well. In reality, it may have been only one stopping place within a much wider seasonal territory extending far beyond the present coast. Then, near the end of the Ice Age, the map began to contract. The sea advanced across the plain in stages. Low river valleys became estuaries. Wetlands shifted inland. Ground used by animals and people was compressed between rising water and the mountain margins. The loss was not one instant catastrophe, but its cumulative pressure was relentless. Each generation inherited fewer familiar routes across the lowlands than the one before it. Groups could retreat, redirect their movements, or cross into neighboring regions. Yet every retreat left part of the archaeological record behind. Camps nearest the advancing shore were submerged. River junctions disappeared. The central plain became a narrowing corridor, then a gulf, and finally the sea that now separates Italy from Croatia. The payoff is unmistakable. The northern Adriatic was once a vast, connected Ice Age landscape used around its margins by hunter-gatherers, and its drowning removed the geographic center needed to understand how those communities moved through the region. The caves survived because they stood high. The paths between them did not. But rising water does not always leave such a gradual sequence. On the next map, the argument centers on a basin, an incoming sea, and the possibility that one regional flood occurred fast enough to survive not only in sediment, but perhaps in human memory. Number 3. The Black Sea Flood. A core of dark sediment lifted from the floor of the Black Sea contains a sharp change. Below it lie deposits formed in a lower, more isolated basin. Above it are shells and sediments associated with marine water. Somewhere between those layers, the sea changed character. On prehistoric maps, the Black Sea may appear smaller than it does today, with broad areas of exposed land around its margins. Rivers entered a basin whose level, salinity, and connection to the Mediterranean changed repeatedly as glaciers grew and melted. Then, water from the Mediterranean began moving through the Bosphorus into the lower basin. That much is real. The argument begins with the speed. One influential hypothesis proposed that the connection produced a catastrophic flood, with seawater pouring northward fast enough to drown large areas in a matter of months or years. In that version, farming communities near the old shoreline would have been forced to flee, carrying memories of a lost world into later flood traditions. The image is powerful. A narrow strait opening, water cutting through, villages abandoned, and families climbing toward higher ground as the shoreline advanced behind them. But does the sediment support a disaster on that scale? Marine shells show that Mediterranean species entered the Black Sea. Changes in salinity and sediment confirm a major environmental transition. Submerged shoreline features and drowned valleys show that water-covered land once exposed around the basin. The disagreement concerns how low the Black Sea stood beforehand, when the connection occurred, and whether the inflow was a sudden torrent or a more gradual exchange. Some reconstructions place the old shoreline far below its modern position. Others suggest that the difference was smaller and that the basin may already have been rising because of river and meltwater input. Dates from shells, coastal deposits, and seabed cores do not always align neatly, partly because material can be reworked, contaminated, or moved after deposition. The map therefore presents two very different human experiences. If the basin was much lower and the inflow rapid, communities near the shore could have lost hunting grounds, fields, fresh water sources, and settlements within a few generations, or perhaps much faster in the most vulnerable areas. A regional event of that kind would have felt absolute to anyone living through it. Their entire known coast could have been transformed without the rest of the planet experiencing the same disaster. If the rise was slower, the danger would have been less theatrical, but no less consequential. Shorelines would still retreat. River mouths would move. Wetlands would become brackish. Families would abandon low ground and rebuild farther inland, repeating that decision as the water continued to climb. So could this be the origin of the Great Flood stories? The evidence cannot connect a particular sediment layer to a specific myth recorded thousands of years later. Oral traditions can preserve memories of real landscapes, but they also change, merge, and acquire religious meaning over time. Similar flood stories can arise independently wherever rivers overflow, coasts drown, or storms destroy settlements. The physical record supports a major transformation of the Black Sea Basin. It does not identify Noah, a single ark, or one flood that covered the entire world. That is the payoff. The Black Sea gives us something more scientifically defensible than a universal deluge. A real regional landscape altered by rising water, whose human consequences may have been severe, even if the exact tempo remains disputed. And that distinction matters for every map in this documentary. The flood was probably not one moment experienced everywhere at once. For prehistoric communities, it may have been many local endings. One plain, one river mouth, one generation at a time. The darker possibility is not that one forgotten civilization vanished beneath the Black Sea. It is that countless ordinary camps and settlements disappeared around its margins, leaving only scattered tools, buried shorelines, and environmental traces too incomplete to name the people who lived there. The next map follows an even harder trail. Along the Pacific edge of the Americas, the most important migration sites may be absent not because the journey never happened, but because the coast those travelers followed is now far beneath the sea. Number 2. The Lost Pacific Coast. On Tri-Kay Island, off the coast of British Columbia, archaeologists uncovered a darkened hearth, stone flakes, and animal remains from a camp used near the end of the Ice Age. The site survived because it stood on ground that escaped complete submersion. Much of the coastline around it did not. A prehistoric map of the Pacific margin shows shorelines displaced far beyond their modern positions. From Alaska to British Columbia and southward along the Americas, lower sea level exposed broad coastal shelves, river mouths, beaches, islands, and protected channels. In some regions, the sea lay kilometers from where it meets the land today. That vanished coast may hold evidence for one of the most important journeys in human history. For much of the 20th century, the earliest migration into the Americas was often described mainly through an interior route between the great North American ice sheets. As the glaciers retreated, people could move south through an opening corridor. But archaeological dates increasingly showed that human communities were already far south before that passage became fully useful as a rich migration route. If people reached those regions earlier, where had they traveled? The Pacific coastline offered another possibility. Travelers moving from Beringia could follow shorelines southward, using islands, estuaries, freshwater streams, marine mammals, shellfish, fish, seaweed, birds, and coastal plants. The route would not have been simple. Glaciers reached the sea in some places. Storms, tides, cliffs, and long crossings created real dangers. Yet the coast also formed a chain of recurring resources that could guide people through otherwise unfamiliar territory. This idea is often called the coastal migration model, or more loosely, the Kelp Highway hypothesis. Its greatest problem is visible on the map. Most of the coast those travelers would have known no longer exists above water. If early groups camped near beaches, river mouths, lagoons, or sheltered coves, their hearths and tools may now lie beneath marine sediment. Rising seas would have drowned low sites first. Waves could scatter artifacts. Coastal erosion could destroy entire surfaces before they were buried. Later geological movement raised some shores while lowering others, making the ancient route different in every region. How can archaeologists test a migration route when much of its evidence has been erased or placed beyond normal excavation? They search for rare pieces of the old coastline that survived. Some islands and uplifted coastal terraces preserve ancient camps. Caves near former shorelines protect bones, tools, and charcoal. Offshore mapping identifies drowned river valleys and landforms where people could once have found fresh water. Archaeologists also compare the timing of sites across the continents, looking for patterns that an exclusively interior route cannot easily explain. No single discovery proves that every early population followed the Pacific. Human movement was rarely one journey made by one group along one path. Some communities may have traveled by coast, others through interior regions, and later populations may have used both. Routes opened and closed as glaciers, ecosystems, and shorelines changed. But the surviving evidence makes the older, simpler story incomplete. Early sites appear thousands of kilometers apart, from northern coastal environments to the far south of the Americas. Monteverde in Chile preserves wooden remains, plant material, stone tools, and traces of habitation dating to a time when a rapid migration through a newly opened interior corridor becomes difficult to explain. Coastal resources found at some early sites show that people were capable of using shore and marine environments, even when the camps themselves were not directly on the ancient beach. At Triquet Island, the preserved hearth offers a more intimate image. Someone gathered fuel, maintained a fire, processed food, and returned to a place along a coast shaped by ice and shifting water. The fire survives because that fragment of landscape remained accessible. Similar camps on lower ground may be gone. The evidence payoff is clear. Prehistoric maps reveal a Pacific shoreline capable of supporting movement southward, while archaeology confirms that people occupied coastal regions early enough for that route to be taken seriously. The missing sites do not establish every step of the journey, but their likely submersion explains why the trail is so difficult to follow. This is the central danger of drowned landscapes. Their absence can be mistaken for human absence. By the time the modern coastline formed, the first travelers had already moved far beyond it. The sea covered their beaches, river crossings, boat landings, and temporary camps, leaving archaeologists to reconstruct a continental migration from the few pieces of ground that escaped. One map remains. It does not focus on a single basin, bridge, or coastline. It restores the exposed continental shelves of the entire planet and reveals that the missing Pacific route was only one part of a global archaeological blind spot. Number 1. The world beneath the water. A stone tool recovered from the seabed off northwestern Australia rests today in a museum tray, but the map beneath it shows where it originally belonged. On dry ground, beside a coast that no longer exists. That single object changes the scale of the investigation. Doggerland, Beringia, Sundaland, Sahul, the Adriatic Plain, the Persian Gulf, the Black Sea, and the Pacific coast were not isolated accidents. They were fragments of one global transformation. At the height of the last ice age, so much water was locked in continental ice that sea level stood roughly 120 meters lower than it does today. On a global reconstruction, the pale blue continental shelves around the modern continents turn into land. Coastlines move outward. Islands merge. River systems extend across plains now buried beneath saltwater. The result is not a strange alternate Earth. It is the human Earth of the late Pleistocene. Along those exposed margins were estuaries, freshwater springs, lagoons, river mouths, wetlands, dunes, cliffs, and sheltered bays. These were not automatically the only places people lived, and they were not always gentle environments. Storms, cold, unstable shorelines, and shifting resources made coastal life dangerous. Yet water, fish, shellfish, birds, plants, driftwood, stone, and animal migration routes could make such zones exceptionally attractive. How much of the human story took place on ground that disappeared before archaeology began? The first layer of evidence comes from geology. Bathymetric surveys reveal submerged valleys and terraces. Seismic profiles trace rivers beneath marine sediment. Cores preserve pollen, freshwater organisms, charcoal, and soils formed in open air. Sea level curves show when each shelf was exposed and when water returned. The second layer is archaeological. Off the coast of Israel, the submerged Neolithic settlement of Atlit Yam preserves stone structures, burials, animal bones, tools, and a carefully built well beneath the Mediterranean. Around northern Europe, fishermen and dredging crews have recovered worked antler, flint, and human remains from areas once joined to the continent. Off Australia, archaeologists have documented stone artifacts resting on drowned surfaces that were accessible before the sea reached them. These discoveries are separated by thousands of kilometers and different periods. They do not describe one civilization, one migration, or one catastrophic day. They confirm something more fundamental. People repeatedly occupied landscapes that later became seabed. The third layer is the map itself. When the reconstructed shorelines are placed beside known archaeological sites, some locations that appear coastal today move far inland. Others that now look isolated become connected by plains. Caves on surviving high ground sit at the edges of territories that once extended toward vanished rivers. Modern islands become hilltops. Narrow seas become valleys. The map exposes a bias built into the evidence we have inherited. Stone tools survive best where someone can find them. Hearths become history only if their charcoal remains in a layer that can be excavated. Burials enter the record when the ground above them stays dry, accessible, and undisturbed. A camp drowned by rising water may be buried beneath meters of sediment, scattered by waves, or destroyed before preservation begins. That means a blank space offshore cannot be read as proof that no one lived there, but it also cannot be filled with imagined kingdoms. The absence of evidence beneath difficult water creates a missing archive, not permission to invent its contents. This is where the final map earns its place. It shows that the world before the flood was not one lost continent waiting to be named. It was a changing belt of human landscapes around nearly every major landmass. Some remained exposed for thousands of years, some narrowed slowly. Others were transformed by regional storms, tsunamis, river changes, or sudden failures along vulnerable coasts. For the people living there, the process was local and personal. A freshwater spring turned brackish. A sandbar vanished. A familiar estuary widened. A burial ground became unreachable. A route known by grandparents ended at open water. No generation needed to witness the full rise of the ocean to understand loss. They only needed to see that the shore had moved again. The strongest evidence does not support a single global wave sweeping over an advanced, forgotten civilization. It supports something more widespread, and, in human terms, more difficult to grasp. Thousands of communities facing different versions of the same pressure as the sea redrew their worlds. Some moved inland. Some changed their diets. Some crossed newly formed channels. Some became separated from relatives and trading partners. Their descendants survived, but many of the places that shaped them did not. That is the final payoff. Prehistoric maps do more than restore missing land. They reveal why the surviving record of human life is incomplete. The sea covered settlements, routes, resources, and meeting places, then left later generations to reconstruct the past from the higher ground that remained. The modern map is not the world our ancestors inherited. It is what was left after the water returned. These 10 maps begin with geography, but they end with evidence. They show that coastlines can disappear, continents can separate, and inhabited plains can leave almost no visible trace above the water. The greatest mystery is therefore not whether lost prehistoric lands existed. Their river channels, sediments, tools, and drowned settlements show that many did. The unanswered question is what happened across the millions of square kilometers that have never been systematically searched. Somewhere beneath modern shipping lanes, fishing grounds, coral, mud, and darkness may lie camps beside forgotten rivers, the first landing places of migrating families, and ordinary objects abandoned before anyone knew the sea would keep them. Archaeology has recovered only fragments from those landscapes. Each fragment changes the map a little, and every corrected map reminds us that human history was not written only on the ground that survived. For another evidence file from the human past, choose the video on screen now and subscribe for the next case.